Hey, in the last video, we talked about parent, sine, and cosine functions and their basic nature of the graph. For example, sine graph or psi cosine theta, the basic nature of parent sine function was that one cycle basically passes through the origin, half mountain, half valley, goes all the way to 2 pi, half of that is pi, half of that pi over 2. This one would be 3 pi over 2. And then amplitude goes up to 1, goes down to -1. And in the parent function, there is no vertical or horizontal shift associated. We only have amplitude 1 and b, which is the frequency, which is also 1 in this case. Frequency sits here, amplitude sits right there, and so on and so forth. Then we also discussed our cosine function in the last video. It's important to know the basic shape of cosine. Cosine starts off one cycle, basically. I'm talking about parent cosine. It kind of starts at the very top and then creates this shape out of it. It looks like a glass if you kind of go about that way, if that's how you want to remember it. And then one cycle, again, stops at 2 pi. I mean, clearly this goes on forever and forever in this direction. But then the basic shape of one cycle is what you want to keep in mind. Period, again, is 2 pi. Half of that would be pi right here. Pi over 2, it passes x-axis. And then 3 pi over 2, it passes x-axis again. Amplitude is the same as sine functions. Okay, let's keep that in mind. And then based off of this is when we start sketching our transformations. Before we even start sketching our transformations, I have a few equations in front of me with all sorts of transformations going on here. Let's be able to identify the amplitude, b, which is period constant, c, which is horizontal shift, and d, which is vertical shift. So to begin, let's write our basic equation that involves the transformations. So if there's a negative in the front, and we'll talk about the job of every transformation associated here. Next would be, this is where the amplitude sits. And if we are just talking about sine or cosine function, so either it'll say sine or cosine here, followed by the b value, open parentheses, followed by x, which is the basic input of the function, and followed by plus minus c, and then followed by plus minus d. And what are the jobs of each one of them? Negative is responsible for reflection of the graph over x-axis. There, b is called the period constant or frequency, which basically tells us how fast or slow the wave is. C is responsible for phase shift or horizontal shift. And D, this number right here, is responsible for the vertical shift of the graph. Sorry, vertical shift. Now, if you recall, vertical shift goes just the way it sounds. +2 would mean the graph moved up 2, -2 would mean the graph moved down 2. Plus minus C, on the other hand, the phase shift works backwards. So if we have minus, let's say, 25 degrees, x minus 25 degrees, that would basically mean a shift of 25 degrees to the right. So it works backwards. Keeping that in mind, let's begin. And of course, I won't do every single one of them, but let's start with, let's say, E. So keep in mind, this will create a reflection of the graph. Amplitude of this graph would be half. B, which is the frequency, that number sits right here between the function and its input. The way you want to remember it is it's the number that's sandwiched between the function itself and its input. And the input can be any letter, theta, x, t for that matter, depending on the application problem. Well, B would be 2. C is 70 degrees, and in this case, it moves to the right, so you can just say right there. And then D, we can call this down 5. Now, based off of this, we can also compute the period of this. Period's formula is 2 pi over b. In this case, it would be 2 pi over 2, which is pi. So this wave will complete one cycle in pi. Also, because the frequency was 2, which means this is twice as fast, so it should complete one cycle in half the time. And that kind of takes care of some of the basic stuff. But also please notice G. This one, B is 3, however, B has been distributed in. For C to be calculated correctly, please know that B needs to be distributed out. which means I need to rewrite this equation, pulling out the 3. And now I have theta of minus 30 degrees plus 8. You just want to make sure that when you distribute the 3 in, we get that 90 back. And you can see how that C value has changed. So this is not the correct C value. For correct C value, you have to distribute B. And now everything is about the same. Amplitude is 8, B is 3, C would be 30 degrees, and this graph has scooted to the right. D, as you can see, would move up 8. So the midline would scoot up 8. Notice how frequency is 3, which means this cycle, this is 3 times faster. Period is 2 pi over b. In this case, it's 2 pi over 3. If you want to see, we'll do one more. This one's not ready either. B needs to be pulled out. That leaves us with 2 pi over 9, because we want to make sure when you distribute this, we get 2 pi over 3 back, and then plus 8. And then from here, amplitude is 8, B is 3, C is 2 pi over 9. We have it in radians, and this again is scooting to the right. And D is up 8. Now period, same thing, would be 2 pi over b. B is 3, so here's the period. Now knowing this, let's start sketching. So my first example here is y equals 2 sine theta minus pi over 4 minus 2. Let's list some of the basics here. As you can see, amplitude is 2, period is 1. Please know it's that number here, and that would never be 0. That's often an error made by students. It's not 0, because if it was 0, everything will collapse to 0, and we will not even have a wave there. So period is 1. C is pi over 4, and you can make a note to yourself that this is scooting to the right by pi over 4. The one cycle has scooted to the right, which means every cycle has scooted to the right. D down 2, period is 2 pi over b. In this case, b is 1, so period stays as 2 pi, which means the period length is the same as the parent. An interval would be take that period and split it into each quarter, so 4 quarters, so pi over 2. Interval is basically the amount we need to add to every quadrant to get the next critical point. It'll make sense in a bit. I already have this labeled. What I'm going to do is I'm also going to split my workspace into 4 quadrants so that my cycle for sine wave is more accurate. And do your best to kind of split it into 4 equal parts. So you'll have to draw 5 lines to get 4 quadrants. So each one represents a quadrant. You may not want to list this every single time, but I'm listing it right now so that you know that this is representing every quadrant. Now, this graph has scooted down to, which means the midline has scooted down to, and that's where you want to start. Also, amplitude is 2, which means from here, the wave goes up 2, and then from negative 2, it goes down 2, which basically means negative 2 plus 2, which is 0, and negative 2 minus 2, which is negative 4. So now you can see here's the midline. This is the midline of the graph. And from the midline, amplitude is 2. It goes up 2 and down 2. Please know that A doesn't just directly transfer here. You have to work through it to make sure that the amplitude overall is 2 from the midline. Then the next thing we want to put down here is the start of one cycle. So we need to list all these 5 critical points. The start point is the shift, which means this is pi over 4. So if the start point has shifted pi over 4, which means every critical point here has shifted pi over 4, which means to get the next point, I would take the start point and keep adding the interval to it to get the next point, which means pi over 4 plus pi over 2. To make it common denominator, multiply by 2, so that changes into 4, that changes into 2. That gives me 3 pi over 4. And then just keep adding. Now that I have 3 pi over 4, keep adding pi over 2. In other words, keep adding 2 pi over 4. The next one would be 5 pi over 4. And by now you can start seeing the pattern, which means next will be 7 pi over 4 followed by 9 pi over 4. And I got all 5 critical points. The total, I have put down 8 elements on the graph so far. 3, 4, 5, 6, 7, 8. Now let's put down our actual graph. Please know that the graph will stay in this zone because a graph cannot go above the range or below the range, above the highest point and below the lowest point. It has to fluctuate between 0 and -4. That's number one. And also each cycle will be in this 4 quadrants. And also keep in mind this is a sine shape, which, like I said, is half mountain, half valley. So starting here, half mountain in the middle, and then half valley right there. And we have only sketched one cycle. This goes on in both directions, but this is more than enough. Next and the last two items that need to go on the graph are x and y axis. Notice that growing up, for the most part, x and y axis was always given to you, and then you had to graph based off of where the origin was. But in this case, it's easier to graph first and then put x and y axis. Now, x-axis is a representation of the 0 on the vertical, and y-axis is representation of 0 on the horizontal. Because this is pi over 4, which is a positive number, which means y-axis will be to the left of it somewhere. And now we have completely sketched the graph of the given sine function using all the transformation listed. I'm going to go ahead and do another example here. Let's see, I'm trying to find something. Yeah, here's a good one. Let's do number 4. Notice how B is sandwiched in, which means it is distributed in. We need to undistribute B before I can start sketching. So I'm going to rewrite this equation. Sine 3, on open parentheses, minus pi turns into pi over 3, and then minus 3. So keep in mind, B needs to be undistributed, so I can clearly see the C value, which is the phase shift or the horizontal shift. Amplitude is 2, period is 3. It's a pretty fast wave, 3 times faster than the parent. Phase shift pi over 3. Keep in mind to the right. Vertical shift here. Actually, in the notes, I'm so sorry. I'm going to go ahead and change it to plus because that's what I did in the class, just so I could show you phase shift to the left as well. So this is now left, negative pi over 3. Vertical shift down 3, period is 2 pi over b, and it stays like that. Interval is period divided by 4, which makes it 2 pi over 3 times 1 over 4, which makes it pi over 6. So each quarter goes up by pi over 6. Let's do our 4 quarters. And this time I'm not going to label them. But as you can see, I drew 5 lines and I've got 4 quarters. Okay, this graph has scooted down 3, which means the midline is at -3. But because the amplitude is 2, plus 2 to that and minus 2 to that. Then comes in the start point. Like I said, this is basically C. But because it's scooted to the left, we are at negative pi over 3. Now to this, I need to keep adding pi over 6, pi over 6, pi over 6 every time. That will give me negative pi over 6, plus pi over 6 gets me a 0, plus pi over 6 gets me pi over 6, and another plus pi over 6 gets me a pi over 3. And all the critical points have been labeled. Now it's time to put on the graph there, but keep in mind, graph will stay in this shaded region. Can't go above -1, can't go below -5. Also, this is a reflected graph of sine, and hence, bottom first, and then the mountain. The valley first, and then the mountain. And the last two things, we're going to put our x-axis. Because this is -1, x-axis is going to be slightly above it at 0. And in this case, 0 is pretty visible right here on the grid, so that will represent our y-axis, and here's the origin. So you can see the graph is scooted down 3, and is also reflected. So this completes the second sine graph with transformations. In the next video, I'll talk about cosine graphs, but also know we could do it backwards as well, which means what if the graph is given and we need to write an equation for it? Because this is 6.1, which is specifically only talking about sine, we need to write sine equations for all 4 of these graphs. So the first thing you want to do is grab one cycle of sine, because all these graphs are showing multiple cycles of sine. Not only multiple, they're also showing incomplete cycles of sine. So you want to grab one complete cycle of sine. I'm going to highlight it so you can see it. Like here, I see half mountain right there. and half valley right here. And this is showing me exactly one cycle. Now where's the midline? Clearly this is the midline, so look for the amplitude. This goes up 4, down 4, hence the amplitude is 4. So we got that from there. Notice how the midline is on 0 on x-axis, so there's no vertical shift. Also, because the cycle originates from the origin, there's no phase shift either. Then let's look at the period, like how long is one cycle? One cycle, this is 2 pi, so 4, 6, and this is 8 pi. So it looks like the period is 8 pi. This will help me determine b, because b is 2 pi over p. 2 pi over 8 pi, getting tight here, which is 1/4. Because now I know a, b, c, and d, I can write the equation based on the same format that we discussed earlier in this video. This is not a reflection, so negative is needed. Start with a, followed by sine, then followed by b, open parentheses, put an x or a t or a theta. Because there's no c value, we close the parentheses right away. There's no d value either. So this completes the equation of the given cycle. Let's try something else. This one's an interesting one. There are several ways to do this. I could grab the sine cycle from here, valley first, followed by the mountain. All I need to do is reflect it, but then also this has scooted to the left. Or I could grab the cycle from here without reflection, half mountain, half valley. In this case, it has scooted to the right. Either way, the equation is going to be right. It's just a matter of how you see it. So I'll keep it to here. Amplitude clearly is 3. Don't forget this is the midline, the green one. So amplitude is 3. Then is there a phase shift? Well, clearly there's a phase shift because this scooted to the right. Phase shift is by pi because that's pi, 3 pi. So it's pi to the right, which means in the equation, c will be represented as minus pi because minus represents scooted to the right. Then comes in the period because I need to find period, which will help me find b. Oh, but before that, let's look at vertical shift. Because the midline is sitting right on x-axis, there was no vertical shift. Now let's find period. It starts here at pi and goes on until 5 pi, because this is 5 pi, which means the period length is, this is from pi to 5 pi, means the period length is a total of 4 pi, because it's 5 pi minus pi. So this is 4 pi, which will help me calculate my b. b is 2 pi over period, which is 4 pi, and that's in half. It's a slower wave, as you can see. A period is 4 pi, which means it takes 4 pi to finish one cycle, whereas parent only takes 2 pi to finish cycle. It's a slower wave. Putting together the equation, f of x, not a reflection, start with amplitude, sine x, oops, I forgot the b. b goes right there. X minus pi to represent scooting to the right. And there's no d, so that completes the equation. I can do another one here. This one, I think most of you will pick the cycle from here, half mountain, half valley, no need for reflection. Amplitude goes to 3, negative 3. D, there isn't any. C, yes, we scooted to the right, so minus pi over 6. Period now is from pi over 6 all the way to 7 pi over 6. So 7 pi over 6 minus pi over 6 is 6 pi over 6, which is pi. The period is pi, which makes b value 2. Frequency is 2. F of x, not a reflection, so 3 sine b x minus pi over 6, and no d. So that completes the equation. Hopefully that was helpful. And in the next lesson, I will start with cosines. See y'all then. Bye-bye.